Bismillahirrahmanirrahim. Welcome to this lecture. We will continue our discussion on Euler's method. In this lecture, we will do some problems related to Euler's method. Uh, Before that, I will refresh you some ideas that we have discussed in the previous lectures regarding Euler's method. So we are going to discuss the Euler's method. Okay. So we have already discussed that a differential equation will be given and we want to solve this differential equation. It is dy by dx, which is the function of x and y. And the initial conditions are also given. Initial conditions are also given. Initial conditions are given as x naught and y naught. And we want to solve this differential equation, that is we want to solve this differential equation. Okay, this is our differential equation and the initial conditions are given. So how to proceed with this? So in Euler's method, actually the x suppose we are starting with x naught, and from x naught we will find x1. How to find x1? X1 is equal to x naught plus h. Okay, and we will also find starting with y naught, we will find y1. Y1 is equal to some y naught plus some delta y. Sorry, not delta x, it is delta y. Okay, y naught plus delta y. And what is this delta y? That we have already discussed this in the previous lecture, and we want to find this function, and we have to find the function y of x. That means the solution of the differential equation. And we are here at x naught and we have y naught. So these two are given. Okay, these two, x naught and y naught, are given. And there is some line actually. So there is some curve. We want to find this curve. There is some curve like this, or maybe like this, or maybe like this. But only information that we have that dy by dx of this curve, dy by dx of this curve. And what is this dy by dx? It is nothing but the slope of the curve. So we have the slope of the curve which is passing through x naught and y naught. Okay, which is passing through x naught, y naught. So according to the slope, we can approximate this is the slope of the curve anyway. So there is some line with that slope. The slope of this line is equal to dy by dx at the point x naught. It is nothing but f of x naught and y naught, because dy by dx is nothing but our differential equation, which is nothing but a function of x naught and y naught. Now if you have a curve something like this, which is having a slope of dy by dx, so you know that you have a point. For example, this is the point x naught, and this is the y naught, and this is the slope of the curve. You can find the next point x1, which is equal to x1 plus h. Then how to find the corresponding y1? How to find the corresponding y1? Because this point is y naught and this is delta y. So your point, this one, is the y1, and we can say that y1 is equal to y naught plus delta y. Now how to obtain this delta y? Delta y by delta x is nothing but the slope of the curve, right? So delta y is equal to slope into delta x. That is, you have delta x, so you have the point x1, so the delta x is nothing but h. So we can replace this delta x with h. Okay, so it is h. So delta y is nothing but y naught plus, so you can see here delta y is nothing but h into the slope of the curve. This is nothing but y naught plus h into dy by dx. And what is this dy by dx? So dy by dx is nothing but f of x naught y naught. Okay, at the point x0, that is f of x0 and y0. You know that the slope is dy by dx at the point x is equal to x0. This is the slope at x0. Okay, slope at x0. So we have the slope. With the slope we will approximate, we will get our x1 and we will find our y1. Maybe there will be some error due to this linear approximation. We can say that this is a linear approximation. Your actual curve may be passing like this. This may be your actual curve. So this is your actual curve, but you are approximating the curve by using a linear approximation, and this is nothing but your linear approximation. Okay, so we can conclude that we will update our x0 by x0 plus h to obtain x1, and we will update our y0 to obtain y1 by y0 plus h into f of x0. So we will continue, or we can say that in general we can conclude that xn plus 1 is equal to xn plus h, and yn plus 1 is equal to yn plus h into f of xn and yn. So this is our Euler's method. Okay, so with this we will continue. Problem: solve the differential equation. Solve the differential equation. Solve the differential equation for the interval 2 to 3. Okay, that means you have to solve the differential equation for the interval 2 to 3. The equation is given as dy by dx is equal to minus x into y square. Okay, and h is equal to 0.1. So this is the problem. So we are going to solve the problem. So by using the Euler's formula, we can find xn plus 1 is equal to xn plus h, and yn plus 1 is equal to yn plus h into the slope. What is the slope? Slope is f of xn yn. Okay. Now we can find the solution here. So for n equal to 0, that means you are going to find, not for n equal to 0, for n equal to 1, or we can, for n equal to 0 you can say, for n equal to 0 you can find x1 is equal to x0 plus h, which is nothing but sorry, I forgot to write the initial condition. Initial condition is also given as h is equal to 0.1, and initial condition is given as y of 2 is equal to 1. That means we will write the initial condition. Initial condition is y of 2 is equal to 1. So what is this? Y of 2, this is x0 and this value is y0. Okay, so we are going to solve the differential equation. So x1 is equal to x0. What is x0? x0 is 2 plus 0.1, which is equal to 2.1. Okay, now we will calculate what is y0 for this, sorry, y1 for this. Y1 is equal to y0 plus h is 0.1, and f of x0 y0, right? F of x0 y0, which is equal to, what is y0? Y0 is equal to 1 plus 0.1 into f of x0 y0 is minus of x0 into y0 the square, which is equal to 1 plus 0.1 into minus x0. What is this? Minus x0 is 2, into y naught is 1 square. Okay, so you will get the answer as 0.8. So 0.8. So you got this x naught and you got, sorry, x1 and y1. Next you will find x2. x2 is equal to x1 plus h, right? So you can get it as, what is x1 is 2.1 plus h. What is h? H is 0.1. H is 0.1. So this is nothing but 2.2. So you got x2. Now you will find y2. y2 is equal to y1 plus h into f of x1 and y1. What is y1? y1 is 0.8 because you got it by using the previous iteration. Okay, so you got it. So plus 0.1 into minus of, what is x1? x1 is 2.1 into what is y1 is 0.8 the square, right? So you will get y2 as 0.6656. Okay, so you got x2 and you got y2. And next you will find x3. What is x3? It is nothing but x2 plus h. So what is x2? You got x2. x2 is 2.2, I think so. So x2 is 2.2, right? x2 is 2.2. So you will get x2 plus 0.1, which is equal to 2.3. So you got it. Now you will find y3. y3 is equal to y2 plus h into f of x2 and y2. And what is y2? y2 is 0. This one 0.6656. 0.6656. And what is h? H is 0.1. And what is this? F of x2 y2 is minus x square y square. What is minus x square? It is minus x square. What is minus x1 square? x2 square. What is minus x2 square? It is 2.2 the square, right? So x2, not minus x2 square, minus 2.2 into y2 square. What is y2? y2 is 0.6656 then square. So you will get this is 0.5681. Okay, next you will find for x, you will find x4. x4 is equal to x3 plus h. What is x3? 2.3 plus h is 0.1, which is nothing but 2.4. You got it. Now you will find y4. y4 is equal to y3 plus h into f of x3 h3. And what is y3? y3 is 0.5681 plus 0.1 into minus 2.3 into 0.5681 square. Okay, so you will get it as 0.4939. So you got it. So in this way you will continue. So you will continue in the same way to find x5, x6, like this up to x10. What is x10? Is equal to 3. Like this you will find y10, maybe y5 up to y10. Okay, now in the question there is one more part in the question. That means you have to compare the result, compare the results with exact solution. What is exact solution? It is also given y equal to 2 by x square minus 2. This is the exact solution for this differential equation. So we will compare our result. So what we are going to going to draw a table. We have xn in general, we can say, and we have our solution using we have our yn, that is the solution using Euler's method. Next we have the exact solution. Exact solution is given by y equal to, what is y? Y is equal to 2 by x square minus 2. This is the exact solution, and we will find the error. Okay, or else I will, in the first column I will use the exact solution, and then okay, so exact solution, that is y equal to 2 by x square minus 2. This is the exact solution. Then we have solution by Euler's method. That's what we have done now, Euler's method. Then the error between these two. What is the error? Error, you can say the error is nothing but the exact value. Error is equal to exact minus numerical solution. Okay, it is the exact minus numerical solution. So we start with actually x naught. We start with x naught. You know, x naught is equal to 2. Then we start with then 2.1. Then x1 is equal to 2.1. Then 2.2, 2.3, 2.4, 2.5, 2.6, 2.7, 2.8, 2.9 and 3. Okay, this is our solution. Then we will find we have y naught, and what is y naught? Y naught is equal to 1. Then y1 we got it. You know what is y1? We have got y1 as 0.8, right? Y1 is 0.8. So this is exact solution table, not this one. This is y naught. Y naught is okay. Sorry. So this is our table we have to fill. This table we have to fill. This is our y naught is equal to 1. And initial condition was given as 1 in the exact solution also. You will get, if you, okay, exact solution we will fill it later. So y naught equal to 1, because this is by using our Euler's method. Okay, by using Euler's method. And y1 you got it. So I will draw the table like this to avoid the confusion. Okay, so this is y1, and y1 was we got it as 0.8. Okay, so y1 is 0.8. Then y2 we got it as 0.6656, and y3 we got it as 0.5681, and this y4 we got it as 0.4939. Okay, you might have seen this. Yes, this is y4, you got it 0.4939. but y5 also you can calculate in the same way. y5 you will get, you check it, 4354, 0.4354. y6 you will get it as 0.3880. y7 you will get it as 0.3160. y8 you will get it as 0.2880, and y9, sorry, I have made a mistake here. Okay, you will get y5 is 0.4354, then 0.3880, then you will get 0.3488, then you will get 0.3160, and y9 you will get it as 0.2880, and this is y10 you will get it as 0.2640. So these are all the solutions that you are getting by using Euler's method if you continue in the same way. Okay, now we are talking about the exact solution. Okay, what do you mean by the exact solution? You just put the value of x in this formula. You know the exact solution is nothing but y is equal to you can get the exact solution is nothing but y equal to 2 over x square minus 2. So you take the value of x and substitute in this equation. Okay, now you can get it as at first it is become 2 by 2 square is 4 minus 2, that is 2 by 2, which is equal to 1. So you can see here the exact solution is 1 and the initial condition is also 1. So the error we can say it is 0, right? Now the next part is 2 by 2.1 the square minus 2. That means 2 by x square minus 2. You will get it as 0.8299. Now if you substitute it, that means the error is exact value minus the value that you have obtained by using numerical technique. Then you will get it as 0.0299. Okay, next you can find 2 by 2.2 the square minus 2. You will get it as 0.7042, and the error you are going to get is 0.0386. So if you continue in this way, I will write the solution. You will get it as 0.6079. You will get here 0.5319, 0.4706, 0.4202, 0.3781, 0.3425, 0.3120, 0.2857. So these are all the values you are going to get. Similarly, the error you will be getting as 0.0398, 0.0380, 0.0352, 0.0322, 0.0292, 0.0265, and 0.0240, and the last one 0.0217. So this is what you are going to get if you compare the results. So you are comparing the results between the exact solution, you are comparing the result between the exact solution, and you are comparing the result exact solution and the solution that you have obtained by numerical method, and this is giving you the error. Okay, error. I hope that this is clear. So solving the problem by using Euler's method is not so difficult, it is very easy, and the formula for calculating the solution is given by xn plus 1 is equal to xn plus h, and yn plus 1 is equal to yn plus h into f of that is yn plus 1 is equal to yn plus h into f of xn and yn. Okay, this is next we will see one more problem. So problem is use Euler's method, okay, to solve the differential equation dy by dx is equal to minus 2 into t into y square with the initial condition is y of 0 is equal to 1. Okay, and it has to be solved in the interval 0 less than or equal to t less than or equal to 0.5. okay, using h is equal to 0.1. Okay, and compute the error also if the exact solution is y equal to 1 by t square plus 1. Okay, now we will solve this problem. Answer: we know that instead of the variable x, sorry, here it is t, okay, dy by dt. Now instead of variable x we have t, so we can update t by tn plus 1 is equal to tn plus h, and also yn plus 1 is equal to yn plus h into f of tn and yn. Okay, because instead of x we are having t. Now it is given that y of 0, that means this is nothing but t0. So t0 is given as 0. So what is t1? T1 is equal to t0 plus h. This is nothing but 0 plus 0.1, which is equal to 0.1. So you got t1. Now you will find, and also it is given y0 is given. You can see here this is y0. So y0 is 1. So what is y1? It is nothing but y0 plus h into f of tn, that means t0 and y0. So y0 is 1, h is 0.1 into you can get it as minus 2 into t0 square into y, not t0 square, t0 into y0 square. Okay, so this is nothing but minus 1, this is nothing but 1 plus 0.1 into minus 2 into t0 is 0 and y0 is 1, so it is nothing but 1. Okay, and next we will find t2 is equal to t1 plus h, which is nothing but 0.1 plus 0.1, which is nothing but 0.2. Now what is y2? Y2 is nothing but y1 plus h into f of t1 y1. And what is y1? Y1 is 1 plus h is 0.1, and what is the function? Function is nothing but minus 2 into t1. What is t1? T1 is equal to 0.1, and what is y1? Y1 is 1. Okay, so you will get it as 0.98. And next you will continue this. You know t3 is nothing but t2 plus h. This is nothing but 0.2 plus 0.1, which is equal to 0.3. Now y3 is equal to y2 plus h into f of t2 and y2. So this is nothing but, what is y2? We have already calculated. Y2 is 0.98. So 0.98 plus 0.1 into minus 2 into what is t2? We have already calculated t2, which is nothing but 0.2 into 0.98 square, because this is the function. Now you will get this answer as 0.9416. Okay, similarly you can calculate, you can continue this. T4 is equal to 0.4, T5 is equal to 0.5, and for that you will get y4 is equal to something, you will get y5 is equal to something. I will tabulate everything in the table. Now you can see that it is given in the question. We have to stop at 0.5. We want the complete solution for the interval between 0 to 0.5. So I will conclude this in a table. Also we have the exact solution. The exact solution is given as 1 by t square plus 1. Now I will conclude this. So in a table, this is yn, and also the exact solution, which is nothing but y is equal to 1 by t square plus 1. Okay, exact solution, and this is the error. Okay, error is nothing but the exact solution minus solution by numerical method. Now for 0 you got 1, and the exact solution is 1 by 0 square plus 1, it is also 1. So the error is, this is the exact solution and this is the solution by Euler's method. Okay, Euler's method. So you will get error is equal to 0. Now you can find for 0.1 similarly like this, for 0.2, 0.3, 0.4 also you can find this. So for 0.2 you will get again 0.1 you will get 1, and here you will get 1 by 0.1 the square plus 1, which is equal to 0.9901, and the error you will get 0.00 minus 0.009. Next for 0.2 you will get yn as 0.98, and here you will get 0.9615. So you can find the error. Okay, similarly 0.88 you will get 8884, and here you will get 0.8621. okay, similarly you can calculate the error. And the numerical solution for 0.5 sorry, I have made a mistake here. This is for 0.3, the answer is 0.9416, and this is 0.9174. okay, and for 0.4 you will get it as 0.8884, and this as 0.8621. okay, and you can calculate the error, and this is what the solution. Similarly you can calculate for 0.5 also. So that's about the numerical solution using Euler's method. Okay, thank you for watching.